In previous lecture, we discussed about classes in C++. Let's briefly continue. Let's briefly review the main points from previous lesson. Abstract data type can be considered as a pair of two sets, set of values and set of operations. Usually set of values specifies the range or maybe not the range, but some interval that in this interval all the values must lie. And set of operations specifies all the possible operations that can be applied to the concrete values of this data type. All the built-in data types have their own set of values and set of operations. Moreover, built-in data types has also the storage structure and binary representation, how these values can be stored in computer memory. And the concept of class more or less corresponds to the concept of data type, because class has set of values and set of operations. And the class in data type can be considered as a user-defined data type with some data and operations. And this new data type, user-defined data type, usually corresponds to some entity from a problem domain. For example, class can correspond to a table. Class can correspond to a rectangle. Class can correspond to database controller, and so on. So the main point of class declaration is that class is a data and operations with this data. When we declare data, we declare so-called member fields. And declaration of member fields is very similar to ordinary variable declaration. And when we talk about operations, these operations called member functions. And a declaration of a member function is very similar to ordinary function declaration. This is a general form of class declaration. We should write a name of the class, then open brace, close brace with a semicolon. Class declaration contains hidden fields and hidden functions, open fields and open functions. Open fields follows after the keyword public. By default, all the class members are private, so this keyword may be omitted. class declaration must end with a semicolon. In the hidden part, we write some implementation details that are not open for user. And in public part, we write functions and fields that are open for users of this class. We consider two particular examples: rectangle and I skip this explanation. And the next example that we start to consider on previous lesson is a class that corresponds to complex number. Complex number in mathematics is a special number that in fact consists of two real numbers that called real and imaginary part. You can read about complex number in any book, even in Wikipedia. You can type a complex number and you can find here a lot of information about this complex number. And this is the usual notation that is used for the complex number. This part corresponds to real part of a complex number, and this number for imaginary part. This symbol I indicates their imaginary part. The real part of this number is 2. The imaginary part is 3. So the complex number can be expressed as a point on a plane where this axis corresponds to the real part, this axis corresponds to the imaginary part. And the point with the concrete values a and b corresponds to the complex number z equals to a plus b I. From the point of view of programming, it's enough to remember that complex number consists of two real numbers, real and imaginary part. This is a declaration of a class. This class contains private member fields v and im and public member functions. These functions used for setting and getting these values real, re and im, because these values are private. These values are closed from other users of this class. And to assign some value for re or im, we must use set re, set im. And to get the values, we must use get re and get im. And for example, to print complex number to the screen, we can use the function print. it's not written. I write it in Visual Studio. Let me switch to Visual Studio. And here, the real and imaginary part outputs to the screen in this form. I can rewrite a function print. I can write several functions with the same name but different parameters. But let me just rewrite the function print. Let's output this number in another form. For example, 3 plus I times imaginary part, something like this. Let's look to this example. I delete the example with the rectangle. I set real part as 2, imaginary part as 3, and call the function print for the complex number C. And we see on the screen 2 plus I times 3 notation for the complex number. Here we stop on the previous lecture. At this point, do you have any questions about it? About classes that class that implements the complex number? Any questions? Okay, no questions. So let's move to the next slide. And now let's discuss about the function add. How to add two numbers. How to add two complex numbers. Let's open the definition. Here I can find in the list of operation addition and subtraction. When we add, suppose that we have two complex numbers a that equals to x plus yi and b u plus vi, and these numbers are added by separately adding their real and imaginary part. So we have the result a plus b that equals to x plus u, the real part, and y plus v, imaginary part. And the same can be said for subtraction. A minus b equals to a minus b equals to x minus u plus y minus v times I. Well, to add complex number, we should pass one parameter of the type complex. But in C and C++, there are two types of addition of two numbers. The first type is similar to the first type corresponds to plus equals operator, and the second type corresponds to plus operator. What is the difference between these two operations? Suppose that we have three integers I, j, and k. Let's review these operations on example of integer numbers. When I write something like I equals to plus j plus k, in this case, j and k are not changed. And the result of addition will be assigned to the variable I. But if I write I as equals j, in this case, the result of this operation is similar to the operation I equals to I plus j. The value of the variable I will be changed after this operation, and it will be equals to I plus j. So, two types of operations. First corresponds to here j plus k, some form of addition that has a result, and this result can be assigned to another variable, and another form of addition that corresponds to the operation where we change the variable I on this way. New value of I will be I plus j. Now let's do the same for complex numbers. Suppose that we have three complex numbers, C, A, E, and C. Suppose I set some numbers for C. Suppose I set some values for E. And after that, I want to call an operation like A equals to C plus B. Something like this. It will look like this. A equals to C add B. I don't write a function add right now. That's why the Visual Studio underlies it with red. But I want to show you the main principle that this operation can be written like this. A equals to C plus B. A equals to C add B. Here, the operation add will be called from the object C with the parameter B, and the result will be assigned to variable A. Well, let's look to their implementation. Implementation of this operation can be written as follows. Let's implement this function here. Complex, for example, Z. Or okay, let it be C. Let it be C capital. We declare here some number as a result. The real part of the result will be real part of this number plus real part of C. And imaginary part will be im plus C im. And return the result. After that, or get rid, of course, set rid. After that, I can call this function and I can print the result. Let's print A. What will we see as a result for A now? What will be real part for A? And what will be the imaginary part? According to the rules of addition, what will we see on the screen? You can type your results in chat. You can answer using your microphone. Is it clear or not? No ideas what will we see on the screen? 4, 4, right. According to the rules of addition, we should see 4 and 4. Or in this notation, 4 plus I times 4. This is the first way how we can implement addition. But you see that in this case, their implementation of their function of the member function can be large, can be complex. Of course, in our case, these implementations are not very large, just 4 lines. But in some cases, implementation of particular method can be very large. And in this situation, it will be useful to divide declaration and implementation of the method. So we can separate declaration and implementation of the methods. First step. We should create the file, let it be just complex.h, and place in this file the declaration of the class. Declaration means declaration of the data members, and declaration of small functions like set and get, and only the prototypes of another functions that can be large. In this example, these large functions are add and print. Only the prototypes. So let's do it. Let me create one more file. In Solution Explorer, I press the button Add New Item, Code, H file. Let's give the name of this H file complex point H. And let's move to this file declaration of the class. This is the first step. After that, our program becomes incorrect because compiler doesn't know anything about class complex. In previous version, the class complex will be defined here, just before the function main. When I move declaration of a class complex into the complex H, this program becomes incorrect. What should I do? I should write here include complex point H. This is first what should I do after that? If you look here, oh yeah, now this program becomes correct. I can compile it. Or one mistake, but I fix it later. Because here cout is not defined. Well, this is the first step. We suppose that these files, these functions are short, and these functions print and add are large. Actually, these functions are not large, but let's imagine that these functions are large. And the first step is to create another file, complex point CPP, and place their implementation of the function. And in complex point CPP, you should also write include complex point H. And you should write implementation of the functions add and print. Let's do it. Let me add new item C++ point CPP, add. Here I should write, I just copy it from my presentation, include complex point H. Well, and here I should place the implementation of the function. Implementation of function print, I move from class complex implementation of addition. I move here. Also, I should fix here this mistake. The function, if it's not an implementation, but just the prototype, should end with a semicolon. It's written here. Prototype must end with a semicolon. Again, this is not an implementation, but only a declaration of the functions print and add. These functions are implemented here. But look, cout is an identifier that is not defined. Yes, of course, because we define cout only in their main function. We must define it again here. I should write include iostream and the namespace std. After that, the program becomes correct. If I run this program, I will see the same result, 4 plus I times 4. Well, let's consider one more time the main points, the main features. I declare a class complex. I put the declaration of the class in a special file, complex.h. I put their definition of the functions in a file, complex.cpp. In this file, I write include complex.h, and before the name of the function add, I write special prefix, the name of the class with 4 points. Here you may see the general form of a definition of the function outside of the class. First, we should write the type of the result. In our case, this type is complex. Then we should write the class name and 4 points. Class name is complex again. After that, name of the function, add, and parameters. Parameter is object C of the type complex. And implementation inside figure brackets. The same can be said for the function print. Function print returns void. Function print belongs to the class complex. That's why I should write complex and 4 points. After that, the name of the function and the parameters. Function print doesn't have any parameters. That's why this is the set of parameters is empty. Well, let's show one more feature for you. Let me show one more feature. Suppose I forget to write this implementation. Yeah, I deleted, I commented. What happens? Let's compile the program. And we see the errors, but these errors will be the errors of linker. not the errors of compiler, but the errors of linker. Linker outputs the message that the function print is unresolved, and the function add is unresolved too. Functions print and add are without definition. It's not a mistake, it's not errors of compiler, but the errors of linker. Now situation becomes correct. Well, this is the first feature. Next feature. I will discuss about it later, but I can show it right now. Here, I use the methods setReal and getReal to get access to the real part of the number C and to set the number for the result. But the same I can write in a more simple way. Result point 3 equals to re plus C point 3. And the same for imaginary part. Result point im equals to im plus C point im. Let's compare these two lines. Of course, these second lines are more readable because these lines are more short, more understandable. The rule, the feature that I use here is that the member function can get access to all their member fields, including private member fields. All other functions cannot get access to member fields, to private member fields. But if their function is a member of the class, in this case, this function can get access to member field. That's why I can write these two lines in a more short form, like this. Okay, let's run. Let's check that we will see the same result, 4 plus I times 4. Okay. Now, let's consider the implementation of another operation that will correspond to plus equals. Let's call this operation append. Let me copy this code from the presentation to the project. And if I just copy, Visual Studio shows me mistake here. What is the mistake? Why Visual Studio shows me the mistake here? The answer is very simple. The function append is not member function because I don't write the prototype of the function in class declaration. I must write here the prototype. After this function, this implementation becomes correct because function append now is a member of the function complex, of the class complex. And I can write here re plus equals c get re, im plus equals c get im, or for simplicity, I can write here just c re and c im, because append now is a member function. How I can call the function append? Okay, let's do it. Let's do it. Now, let's write some operation, something like this. A plus equals C. What should I write to carry out this operation? A point append. You see that Visual Studio shows you this hint, append E. And let's output the value of A on the screen. We remember that after this operation, the value of A is 4 and 4. If I call the function append, A point append C, what will be the new value of A? If the previous value was 4 and 4, and the value of C is 2 and 3, what will we see on the screen? Please write your answers in chat or tell me your answers using your microphone. What will we see on the screen? The value of A after this operation is 4, 4. The value of C is 2, 3. And I call the function append. No idea. Six and 7. We should see 6 and 7, right? 4 plus 2 is 6. 4 plus 3 is 7. Okay, let's output. End of line. Six plus I times 7. If I change the objects, if I write C append A, and after that I print A on the screen, what will we see on the screen now? I just changed the parameters. Not A append C, but C append A. Now the value of A will not change. It will be the same. And we'll see 4 and 4 again. Well, there are a lot of questions here, a lot of problems, but we will fix it and we discuss about these problems later. Yeah, let's fix a few main points. The function add implements the operation A plus B. This is the prototype of the function. The function add has one parameter C and one result parameter. Suppose that the function C, sorry, no, not function, class. The object C is large. Of course, it's not our case, because in our case, the class is rather small. It contains just 2 real numbers. But imagine that this class is large. And for the large parameters, it's better to pass a reference. In this case, this argument, this parameter, will be passed by reference, and transmission of the parameter from the main function to the subordinate function will be much faster, as in this case, because in this case, a copy of actual parameter must be created in a subordinate function. Let's do it. Suppose I create a function complex add with the reference complex C, right? If I change the prototype here, if I change the prototype, but I change the parameter of the function, I also must change it in implementation. Well, but in this case, the function can change the value of C because I pass here a reference. Suppose I write here some strange operation C point real equals to 0 and C point im equals to 0. Of course, it's completely wrong, but I write it. It will be okay from the point of view of compiler. Compiler outputs your no mistakes. But if I call the function add, and if your output after the function add the value of b, you will see that b becomes 0 after you call the function add. The initial value of b will be spoiled by the function. Initial value of b was 2, 1, but inside the function add, I assign 0, 0. Of course, this situation is not good. Of course, the operations plus and plus equal shouldn't change the argument, and the solution to this problem is very simple. We should write const and reference. Constant reference. In this case, not a copy, but reference to actual parameter will be transmitted to a function, so their transmission will be fast. But this reference will be constant. It means that any change of the parameter will be prohibited. Let's do it. Let's write here not only a reference, but constant reference. Const complex C, and also here. If you write const, Visual Studio shows you a mistake here, because you cannot assign a value to a constant object. You cannot change the value of parameter. And now the program becomes correct. Okay, the same can be said for the function print, because print can change the value of the function, the value of the members. Suppose that inside the function print, I write some wrong operation, re equals to 0. It's completely wrong, but I do it. What happens in this case? If I print the value of a, after that, if I try to print the value of a for the next time, I will see 0 as a real number, as a real part of this value. The first value of a will be 4, 4, and the next value 0, 4, because the function print changes the value of the object, but it should not. Function print should just print the number to the screen, but not change their value. To avoid this mistake, I can write the keyword const here after the, sorry, it's not append. It's not the function append, but print, of course. After the function print, I can write the keyword const. Like this. It means that if you write the keyword const after the prototype, this function cannot change the member field of this class. And this situation, when you call the member function and this function changes their value of their member fields, never happens in this case. So if I write const here in the prototype, I must write const here in the definition. And if I write it, Visual Studio shows this line as incorrect. I cannot change the value of the member fields here. So I must delete this line to avoid this mistake. And now the function, the method becomes correct. The method print doesn't change the value of the function, the value of the data members. We see 4 in both cases. Const here and where is it? Complex H. Const here. Well, I can say for the function add the same, that the function add, it doesn't change the value of the class. And the function add also can be declared as a const. But the function append, it cannot be declared as a const because append changes the value of the data members, re and im here in this operation. Well, the main feature of the constant function is that the constant function cannot change the member fields of this class. And the constant function can call only constant methods. And constant member function can be invoked for all objects, not only for constant ones. So this is their next iteration. The declaration of the class complex that is much better than before, but still needs some work because there are some mistakes here also. Not mistakes, but some things can be simplified here. The main points that we consider is using constant reference as a parameter and the constant function. Well, and as the last slide of this presentation, some kind of joke. The more I study, the more I know. The more I know, the more I forget. The more I forget, the less I know. The less I know, the less I forget. The less I forget, the more I know. So why then study? The answer is why the study. to be a specialist in computer science and software engineering. Well, this is the last slide of this presentation. Do you have any questions about the declaration of the methods, declaration of data in the class? Do you have some questions about it? Well, if you don't have any questions, we start the next topic. Let me open the next presentation. So we consider it in this lesson. This is the declaration of a class complex. Well, now we know how to create classes, but how to create objects? We should understand what is the difference between class and object. Class is similar to data type. Object means a particular variable of class data type. So when I said class, I mean user-defined data type. When I said object, I mean a particular variable of this data type. There are two ways to create an object. Static declaration, usual form of a declaration, class name and object name like variable. Let me switch to Visual Studio. I also use this way of declaration. I declare an objects A, B, and C of the class complex. This is the first usual way, and more complicated way, dynamic, when I declare a pointer to the class name, pointer to the data type, and create a particular object using operator new. This line explains how to create objects A and B statically. And here, A, let it be PA, pointer A, will be pointer to the class complex. Also, there are more complicated examples that will be considered later. So instead of usual declaration like A, B, C of the type complex, I can use also this form of declaration. I declare a pointer and create a class complex dynamically. In this case, in the end of the program, I must delete the object to which the pointer PA points. How to work with members, data and functions. I can create a complex number. I can call their data. Sorry, not data. Member functions. I also show you here in these examples, but I cannot get access to their data members because all the members are private. But if, let's use PA, if PA is a pointer, in this case, I can do the same, but instead of point, I should write star. Let's do the same for PA. PA set re1, PA set im 5, PA arrow print. Instead of point, I use arrow, minus and less than. And we will see on the screen here 1 plus I 5. The value of the object PA. But again, the member fields are not accessible. If I try to get access to real number or real part, Visual Studio outputs me a mistake. Cannot access private member. All the members are private. Well, this diagram described in detail how their data members are stored in their computer memory. Suppose that this is the memory, computer memory, random access memory. This is an object A with some real and imaginary part. This is an object B with some real and imaginary part. The data members for these objects are different, but the implementation of the methods are the same. It means that if I call the function setRe, this value 1 is written to the object A. If I call the function r.setIm, this value will written in the object A. But if I call the same function for object B, values 2 and 3 are written in the object B. But when I write this implementation, there are no A and B. The objects A and B, these objects appears only in the main function. And the question how it works, how the function setRe knows for which object it should write the real part. And this problem is solved with so-called this pointer. The answer to this question is as follows. Every member function is called for some particular object. And every member function has one latent parameter, the pointer to the object which calls it. And this pointer is accessible as this. So this pointer, the pointer has a special name, reserved word, this. When you write the function set re on the following way, actually, it means that you write void set re int underlie re this arrow re. It means that the member field re will be taken for the object to which this pointer points. These two implementations are identically equals. And actually, when the object calls the function set re, this function gets one more parameter, hidden parameter, this. And this pointer points to particular object, A or B. Let's come back to this example. Here, data member re is taken from this object. Im is also written with these from this object. And the implementation will be the same. In obvious cases, the pointer this can be omitted, because here, for the method get re, we should just return 3 and that's all. You can write, of course, you can write return this arrow re, but it will be more simple just write return re. And in the main function, when you call the function set re, this function has one hidden parameter, the pointer to the object which calls it. In this line, line 45, parameter this points to the object C. Line 46, parameter this points to the object B. And on such a way, the function set re knows to which object the real part must be written. Well, the notion, this feature, the pointer this is very, very important. Very, very important. And if you understand how it works, you understand maybe the basis for the future work with classes. Well, do you have any questions about pointer these? Okay, no questions. Well, I think it's enough for today. And next lesson, we will start our discussion with we will start our lesson with discussion about constructor and destructor. And after that, we continue this presentation and we will consider some features related with this pointer. Well, if you don't have any questions, I stop recording.